Welcome to the Math 1, Unit 7, Lesson 1, Lesson Summary Video, Children's Barnyard. This lesson is a Develop and Solidify Understanding task, which is meant to both introduce you to a concept and help you formalize ideas. The purpose of this lesson is to build fluency around adding and subtracting linear expressions and interpret the resulting expression in context. The NC State Fair Planning Committee is working on the layout for the Children's Barnyard, which is an exhibit that allows fair visitors to get up close and personal with farm animals. Their plan for the layout is shown in the figure on the screen. All of the measurements are in feet. So we're going to use what we know about geometric figures to find the perimeter of each of the animal pens. Well, in order to find the perimeter, we need to know what each of the outside dimensions of each enclosure are. When we look at the cow enclosure, we're given two of its dimensions, and it's a rectangle, so we know that the opposite sides of a rectangle are congruent, so we have all of the dimensions necessary to find the perimeter of the cow pen. The same thing with the ducks. We know that if the left side is 4x, then the right side is also 4x, and given that the base of the cow pen is 5x plus 2, which is the same distance for the base of the duck pen and the top of the duck pen, we know that these two dimensions are also 5x plus 2. In order to find the top of the goat's pen, we're going to use the information that's already provided here, the 6x and the 5x plus 2. When we combine these two distances and we subtract them from the total distance all the way across the entire layout, that will leave us with the top dimension of the goat pen. So when we add our 5x plus 2 and our 6x, we get a combined first term of 11x's. And then we have these two extra feet here that we are not adding to any extra feet here. So our resulting expression is 11x plus 2. When we subtract this from the 17x plus 11, that will leave us with 6x plus 9. Again, we have 17x minus 11x leaves us with 6x, and 11 minus 2 leaves us with 9. Now that we know the top portion of the goat's pen, that also tells us that the bottom portion is the same. We are still missing this little section here for the sheep pen. So we have this top portion all the way across is 6x. And we have the section from here to here that we know is 5x minus 3. So if we subtract this 5x minus 3 from the total distance all the way across the sheep pen of 6x, that will leave us with what is left here. So if we subtract 5x minus 3 from 6x, 5x minus 6x, 6x minus 5x leaves us with 1x, and 0 minus a negative 3, 0 minus a negative 3 leaves us with a positive 3. We can add this portion to this portion to check and make sure that we got the correct answer, because we know that when I add this section to this section, that should equal 6x. Well, if I add positive 3 to negative 3, that equals 0, and I have no constant here. And if I add 1x to 5x, that gives me my 6x here. Next, we're going to look for this missing dimension on the right side of the goat's pen. What I know is that this section is 4x and this section is 5x minus 2. If I add those together, I get a total combined distance of 9x minus 2. So 4x plus 5x gives me my 9x, and negative 2 plus nothing gives me negative 2. if the total distance from the top of the entire exhibit to the bottom of the entire exhibit or layout is 9x minus 2, then I know it must be the same from the top all the way here to the bottom all the way here. That must also be 9x minus 2. I'm given the 3x plus 4, so I know that I need to add this section to the 3x plus 4 to get me a total combined distance of 9x minus 2. That's one way to look at it. Another way to approach it is to start with the 9x minus 2 and subtract the 3x plus 4, and that will leave me with this distance. So if I start with 9x's and I take away 3x's, that leaves me with 6x's. And if I start with a negative 2 and I subtract 4, that's going to leave me with negative 6. So 9x minus 2 minus 3x plus 4 gives me 6x minus 6. Now that I have the dimensions for each of the pens, I can find the perimeter for each one. So when we look at the duck pens first, I know that I have 2 side lengths, which are 4x, and 2 side lengths, which are 5x plus 2. And you can see how we wrote that here. And when we simplify, we get a total perimeter of 18x plus 4. For the cow pen, we've got 2 dimensions, which are 5x plus 2, and 2 which are 5x minus 2. And again, once we write that up and simplify, we get a total perimeter of 20x. For the sheep pen, I have a top distance here of 6x. Then I have a distance here of 6x minus 6, which I know because I know that this side is 6x minus 6. I'm adding the x plus 3. I'm adding the 3x plus 4. I'm adding the 5x minus 3, and then I'm adding this total distance here, which is 9x minus 2. And we know that from here as well as here. Altogether, that gives us a perimeter of 30x minus 4. And when we look at our goat pen, we have 2 side lengths, which are 6x plus 9, and 2 which are 6x minus 6, which gives us a total combined perimeter of 24x plus 6. So number 2 asks us to find the perimeter of the total combined area for the duck's pen and the cow's pen. There are 2 different ways that you can view this problem. You can interpret this as the perimeter just around the outside of both combined, which would give us, the 5x plus 2 plus the 4x plus the 5x minus 2 plus the 5x plus 2 plus the 5x minus 2 plus the 4x. Or you could look at it in terms of taking the perimeter of the duck pen and adding that to the perimeter of the cow pen. In that second case, you would be using this middle section or this shared section twice. So you'd be including it in the perimeter of the ducks as well as the cows, which would give you a larger total combined perimeter. So when we look at the first example here, and we take the total perimeter that we found for the cow pen, and we add that to the total perimeter that we found for the duck pen, in this model, we're using this middle section here, or this shared wall, twice. And so that would give us a total combined perimeter of 38x plus 4. In the next example, if we only use the 4x, the 5x plus, we're down here, the 5x minus 2, the 5x plus 2, and the 5x minus 2, that gives us 5x plus 5x plus 5x, which is 15x, and then negative 2 plus positive 2 plus negative 2 gives me negative 2. So that's only using these 3 sides of the cow pen. If we add that to the 3 sides of the duck pen, the 4x, and the 5x plus 2, Then we have 4x plus 4x is 8x, plus 5 more x is 13x, plus our 2. That's how we get this expression. And so when we add those two together, negative 2 plus 2 is 0, and 15x plus 13x gives us 28x. The second problem, or excuse me, number 3 says, how much bigger is the sheep pen than the duck pen? So if we start with the sheep pen, which we found had a perimeter of 30x minus 4, and we subtract the total perimeter of the duck's pen, which was 18x plus 4, 30x minus 18x leaves us with 12x, and negative 4 minus 4 more gives us negative 8. Number 4 says, since your answers are expressions, what does x represent in each of these answers? Well, x is going to represent the number of, or one section of prefabricated fencing material. So at the hardware store, you can buy sections of fencing material that comes typically in 4-foot or 6-foot or 8-foot lengths, but the space you're enclosing is not a multiple of 4, 6, or 8. The expressions represent the number of sections of fencing plus or minus extra footage. Number 5 says, if x equals 7, what is the perimeter of the sheep pen? So if we start with the original expression that we came up with to represent the perimeter of the sheep pen, and now we know the value of x, we can substitute that value in place for x and simplify our expression, and what we get is 206 feet. Number 6 says, if the perimeter of the sheep pen is 100 feet, what is x? So we're going to start with the same expression for the perimeter of the sheep pen, 30x minus 4, but now we know the value of that expression, and it is 100, so we'll set that equal to 100. We'll use the properties of equality and inverse operations to solve for x. When we add 4 to each side, we're left with 30x equals 104, and when we divide both sides by 30, we're left with x is approximately 3.47 feet. From here, you should be able to answer the rest of the questions in this lesson.